Welcome to Chapter 5. We're going to start out by taking some derivatives of natural logs. But before I do that, I need to go back and review the three laws of logarithms from Algebra 2. Being good at these is going to be a shortcut in your calculus step-by-step procedures. We have the product law, quotient law, and power law. And remember that logs are really a form of exponents. And you may remember when you first learned how to multiply and divide exponents, it was kind of weird. You ended up adding and subtracting. The same thing is true here. A log is just an inverse of an exponent, really. So if you were going to take two numbers, and we'll refer to them as A and B, so they can be generic, you're going to multiply them together, the logs will get added. And similarly, if you're going to divide, A divided by B, you'll subtract. And again, it's because of the exponential nature of logarithms. And finally, there's the power law. And the power law just simply says, hey, B can come on down and land safely in front. I tell a story every year, and I'm going to tell it again. And this is actually a true story, believe it or not. I had a cat. We got this cat when I was in first grade. That's why it's named what it is. Her name was Fuzzy Ears. She had all this fur coming out of her ears, and it was kind of cool. So we called her Fuzzy for short. And Fuzzy lived until she was 19 years old. Like I said, I got her as a first grader, and my wife actually met the cat before the cat passed away. So we've had this cat a long time, almost 20 years. And one day, when I was in fifth grade, the cat disappeared, and she was gone for about 3 days. We thought she had died. We were like, oh my gosh, we had posters up and stuff. My brother ends up finding her up real high in a tree in our front yard, and she had climbed up there somehow and couldn't get down. And the lowest branch was a good solid maybe 12, 13, 14 feet up. And so, we couldn't reach her. So my mom said, hey, Ken, my dad, can you get the cat out of the tree? Well, my dad didn't like the cat. And he was like, oh, fine. So he gets an extension ladder and props it up there, and the cat's terrified. So my dad climbs up there to try to grab her, and she just scratches the heck out of his forearm, just nails him a few times. He's like, damn it. He comes down, and he's like, the cat could stay up there. She could just die up there. And we're like, Dad, no, gosh. So we had a friend who's a fireman. His name is Chip Davis, a Macedonia Fire Department employee. And so he came over to the house with his, spiky boots and climbing gear and like a leather strap that he put around the tree. He scales up this tree to get the cat down. And of course, at this point, it's a spectacle. We lived at the end of a dead-end cul-de-sac. And so everybody rode their bikes up. This is before cell phones and everything, but everybody knew that this was happening. So we had about 20 people watching this scene. And he gets up there, and Fuzzy's like, hissing at him. And he's like, oh, I don't think so. And so he comes down, and he goes, do you have anything that I can just kind of hit her with, if it's okay with you? They say the cats land on their feet. He goes, I think it's the only way we're going to get her down. So my dad's like, here, yeah. So he grabs this big oversized branch. It wasn't even really a branch. It was more of a tree, like a log. And he hands it to Chip. So Chip goes back up the tree with this climbing gear and this log. He starts tapping Fuzzy with it, and she loses her balance. And finally she falls out of the tree. And she did it looked like this. It was like, she flipped 3 times, and she landed on her feet, and she ran across the yard. Everybody clapped, everybody was clapping. They're like, woo, saved the day. And, she lived with us for another 15 years or so. But long story short, why am I telling you this? Well, here's why I'm telling you. In algebra, if you ever have something up high in the exponent, like a b, it's up high, and you can't get it down, you got to hit it with a log. Woo! And the only thing I regret is that we're not live in class, and I can't see the anguish on your faces right now as you're like, oh my gosh, what a dad joke. But it's true. I've had so many students come back from college, and they're like, I still tell that log story to my dorm floor. I'm like, you tell the log story to the kids in your dorm? And they're like, yeah. I'm like, do you have any friends? Oh, no, they said, but it's really effective. It's really helped people. They're like, oh, that's awesome. So, hey, for what it's worth. All right, so that story that I just told you has a name. It's called the power law. All right, let's get on with it. All right, I've coded some things. I'm going to call natural log of 2a B will be natural log of 3, and C will be natural log of 5. I like to do this so that you can't just completely depend on your calculator for answers. You have to know the laws of logs. It's a way for me to kind of really test your knowledge. We want to rewrite a natural log of 40 in terms of A, B, and C. So I'm going to break the 40 up. I think I'll go ahead and break it up into 10 and 4. So the natural log of 40 will become the natural log of 10 plus the natural log of 4. Again, I'm using the product law here. I didn't have to pick 10 and 4. I could have picked 20 and 2 or 8 and 5. It doesn't matter. In fact, if you want to pick a different one, go ahead. It'll be just fine. I'm going to continue on in my next step, which will be blue. I'm going to break down the natural log of 10 into natural log of 5 plus natural log of 2. Again, using the product law. And the natural log of 4 will become natural log of 2 plus natural log of 2. Or if I want, just for some variety, I'll call it the natural log of 2 squared. And just like my cat Fuzzy, since we do have a natural log, this 2 is allowed to come down safely to ground level. That part will be 2 ln 2, which would have been the same thing if we just had chopped up natural log of 4 into natural log of 2 plus natural log of 2. That would have also given us 2 ln 2. So there is flexibility. If we bring the rest down, you can see that that's going to give us natural log of 5 plus 3 natural log of 2. Of course, my directions say rewrite the following in terms of A, B, and C. So we need to make the conversion. Remember that natural log of 2 is A, and natural log of 5 is C. So the answer is going to be 3A plus C. As a teacher, I love making problems like this one because they're super easy to check, but also you can't use your calculator and just blindly type. You have to know the laws. All right, let's try a couple more of these. Here we have the natural log of a fraction. It's the natural log of 50 81ths, and I want to undo the fraction using the quotient law. All right, we'll take each of these parts separately. We'll start off with a natural log of 50. When I see natural log of 50, I think, well, how about natural log of 25 plus natural log of 2? I'll go minus, comes down. And 81 happens to be 3 to the 4th, so I'm going to say minus natural log of 3 to the 4th. However, using the power law, we can bring the 4 down and sit it in front. So it'd be 4 ln 3. I'm going to try a similar approach over here. 25, keep in mind, is 5 squared. Let me rewrite that as 5 squared. But again, the power law can allow this to tumble down safely, just like my cat, and become a coefficient instead. All right, we're ready for the final answer. I'm going to try to write it alphabetically. So we have natural log of 2, which is an A. Minus 4b, because remember natural log of 3 is b, plus 2c, because c is natural log of 5. Again, I just put the a, b's, and c's in so that you can't just type in this thing on your calculator and give me some 10-digit decimal, and I'm like, yeah, you just used your calculator, and you're like, I want to make sure that you understand your Algebra 2 behind the scenes. It's going to make the calc much easier if your Algebra 2 is strong. On to number 3. People see the 675 and they're like, oh, such large numbers. I'm like, think of money. If you had $6.75 in quarters, how many quarters is that? And suddenly people get really good at mental math when you give them money. They're like, oh, it's 27 quarters. Because, 28 would be $7. I'm like, yeah, so 675 you're saying is 25 times 27. Okay. Now at this point, I could go a couple different ways. I just used the product law. I could use the product law again and just chop the 25 and the 27 down into a bunch of different things. But I'm going to use the power law instead. It's a little faster. I'm going to change the 25 to 5 squared. And I'm going to change the 27 to 3 to the third. And now we bring the power law into play. The 2 comes down. The 3 comes down. They both turn into coefficients. And I'm ready to write my final answer, which is 3b plus 2c. And there you have it. Sometimes you're going to find it advantageous to either expand a logarithm or to write an expression as a single log. So we'll take a couple more practice problems from your Algebra 2 class before we get into the calculus. This one wants us to expand the expression using the 3 properties of logs that we just saw: power, product, and quotient. All right, in this case, we'll start out by rewriting this as natural log of x to the 5th, y to the 4th, quantity to the 1/3 power, because again, a cube root is a 1/3 power. All right, well, next up, since I have a power and I really am not excited about it, let's use the power law to bring it down. So the 1/3 is going to come down in front as a coefficient. That's okay to do as long as you have a log or a natural log. You can't just do that in normal math. I don't ever want you to think that in an Algebra 1 class, if you're tutoring somebody and you have something like x to the 5th, you can't just bring the 5 down and make it 5x. You know that x to the 5th and 5x aren't the same thing. But if you have a log or natural log in front, yeah, that's okay. Then you're actually using the power law. Okay, good talk. Next up, let's break this up. When it says expand, we don't want any exponents. We want everything to have just pluses or minuses. We don't want any exponents. We don't want any multiplications whenever possible. So I'm going to change this part right here to natural log of x to the 5th plus natural log of y to the 4th. The 1/3 will still be in front. And of course, my next step is to use the power law and bring the 5 and the 4 down, making them coefficients. And this could be your final answer if you choose. Or if you prefer, you can distribute and write it like that. I kind of like the lack of parentheses, but either one is perfectly fine. Number 5 wants us to write the expression as a single log. Single means the word log only should appear once on the page, or the word natural log. By the way, I don't know why natural log isn't NL. That seems like it would make more sense, natural log, but it's log naturel. Like, I don't know if it's French or what, but anyway, it's always bothered me. Let's go ahead and bring this 3 up. And we'll bring the 1/2 up. It's kind of like throwing the cat back up into the tree. I mean, we wouldn't do that quite as often, but it's still okay to do. So this is mathematically at least. So this is going to be natural log of 2 to the 3rd, which would be 8. And this would be plus natural log of 49 to the 1/2. And of course, 49 to the 1/2 power is 7. Natural log of 8 plus natural log of 7 is natural log of 15. I'm just kidding. Don't do that. 3, 2, 1. It's the product rule, my friends. It's the natural log of 56. Make sure that your Algebra 2 is solid before going on to derivatives, which is what we're going to do right now. As you notice, we haven't done a single lick of calculus yet. That's about to change. You've noticed for years that on your calculator you have the LOG button, which is common log, that's log base 10. And then you have the LN button, which is the natural log, which is log base E. Truth be told, natural log is used way more in mathematics than common log. Sure, common log is used in chemistry for, pH. It's used in seismology, in the Richter scale, the decibel scale for measuring noise intensity. That's also, LOG, base 10. But pretty much everything else in the world is natural log. And one of the main reasons for that is natural log has a sweet derivative. The derivative of natural log is just 1 over x. Or I should say, 1 over stuff. And there is a chain rule involved as well. All right, let's dive in. Number 6. Well, the derivative of natural log of 3x is 1 over 3x. It's 1 over stuff. Again, this stuff inside has a mathematical name. It's called the argument, which is a strange thing to call it, but that's what it's called. And then you have to do a chain rule. Does the argument, does the 3x, have its own derivative? And the answer is, yeah, of course it does. It's times 3. I'll make that a 3 over 1. Disappointingly, the 3's cancel, and the answer is just 1 over x. All right. That's it. Let's try number 7, same sort of thing. dy dx, the derivative of y with respect to x. It's natural log, so the derivative would be 1 over stuff, or 1 over 11x. Times a chain rule, the derivative of 11x is, well, 11. Make that 11 over 1. The 11's cancel away, and the answer is, you guessed it, 1 over x. Yeah. So you're probably wondering, is it always 1 over x? And the answer is no, it is not. But I must tell you, if you're on a test or quiz and you're lost, 1 over x is a great answer to guess with because it's right a lot more than it's wrong. It doesn't matter if it's a natural log of 3x, 11x, 100x. It will be 1 over x for any of these cases. Now, if I want to jazz the problem up a little bit, I would do something like number 8. Well, the derivative of natural log is going to be 1 over argument, 1 over 2 over x. Eventually, that's just going to become x over 2. I'll clean that up in a moment. Times the chain rule. Now, don't use a quotient rule unnecessarily. I mean, it'll still work, but it's just a time waster. This 2 over x can be thought of as 2x to the negative first. So when you take the derivative of that, it's going to be negative 2 x to the negative second. And I've created a real mess for myself. Let me go ahead and simplify this. As I mentioned just a couple moments ago, 1 divided by that is just simply going to be x over 2. And negative 2 x to the negative second can be rewritten as negative 2 over x squared. The 2's can cancel. One of the x's can cancel with the other x. And you're left with negative 1 over x. See, the answer isn't always just 1 over x. Sometimes it can be negative 1 over x. Who says I don't have variety in my life? Of course, if you want some real variety, let's throw some trig in there. Find dy dx. Well, your first step, of course, the derivative of natural log of anything is 1 over thing. So in this case, it's going to be 1 over sine of x. Times the derivative of said thing, derivative of the argument. The derivative of sine of x, of course, is cosine of x. And the answer is cosine of x over sine of x, also known as cotangent of x. There it is. Now, of course, the problems can't stay easy forever, so we have this. Now, the first thing that people may want to do with their newfound formulas, they're like, oh, 1 over stuff. It's going to be 1 over, and then they dump this all in the denominator. And then when they have to take the chain rule, it ends up being a product rule with a square root in it. And I'm like, no, don't do that. That's so much harder. Use your Algebra 2. I didn't do like 4 or 5 slides of Algebra 2 in the beginning of this lesson just for nothing. I'm not your Algebra 2 teacher. But Algebra 2 can be a big help and a huge time saver. Let's go there first. Let's rewrite the original problem. You've got the natural log of two things multiplied together. Why not use the product law? That's going to be the natural log of 2x to the fourth, I'll put some parentheses around that, plus the natural log of x plus 10 to the half power. All right. Continuing on with algebra 2, I can bring the 1/2 power down as a coefficient. I can put it here, again, using the power law. That takes the square root out of the problem. Now, a lot of people are going to try to bring the 4 down as well. You can't do that because you're leapfrogging over the 2. Only the x's to the 4th power, not the 2. 2 to the 4th would have been 16. You know, Chip Davis, the firefighter from Macedonia, he knocked the cat out of the tree. He didn't throw the cat across the yard. Okay, you can only jump over one thing, not like 2 or 3 or 4 or 10 things. Okay, don't whip the 4 out of the tree. It has to make a nice easy fall. So you cannot do that there. I see so many people trying to do bad algebra. Don't do it. Now I'm going to take a moment just to clean this up a little bit. Even though you can't bring the 4 all the way down in front, you can realize that there is a dot right here, and there is a multiplication. So you can rewrite this part as the natural log of 2 plus the natural log of x to the 4th, using the product law. Now the 4 can come down. See how it still didn't get in front of the 2. It only gets in front of the natural log of x part. All right, let's come up here, do another rewrite. Notice that I have still not taken a derivative. Everything I'm doing right now is algebra 2, but I'm making it easier for myself. All right, finally, after a couple steps of algebra 2, I'm ready to take some derivatives. What's the derivative of a natural log of 2? Well, it's 0. Ha! Because remember, natural log of 2 is a number. Natural log of 2 is 0.693. There's no x's in it. All right, the derivative of 4 natural log of x is just going to be 4 over x. Remember, the 4 is a coefficient. It can come down. And then the derivative of a natural log of x is just 1 over x. That bothers some people. They're like, wait a second, what did you just pull there? I'm like, all right, fine. Here, let's do this. I can put a dot in there. If you want, I can use product rule. I don't need to. This is a bit of a waste of time, but I think it'll convince people. If you call the u the 4, and the v will be the natural log of x, you have u prime v, which would be 0 ln x, which I won't write, plus u, come on down 4, u v prime. And v prime, of course, is 1 over x. So yeah, this is legit. So to save time, just if there's a number in front that's a coefficient, like a 4, just bring it down. All right, and then plus, same thing, the 1/2 being a coefficient just comes down. The natural log of x plus 10 will just be 1 over x plus 10. You look for a chain rule, but it's just times 1, so who cares? And the final answer will be 4 over x plus, and then you've got an option here. You can leave it like this if you choose. You can call it 1 over 2x plus 20. What I do not want you to do is get common denominators between these two. Leave it like this, please. Don't do the extra work. Don't make me do the extra work to check you. I'm not being lazy, I'm being practical here. The reason why is, in real life, the reason you take derivatives is to find slopes of things or rates of change, and you're going to be plugging an x in, you're going to be plugging a number in. Why on earth would you want to make this more complex before you plug things in? Why would you want to make squares or maybe even cubes in some cases? You wouldn't want to do that. So leave your answer as 2 separate fractions from now on. Great. All right, let's try this out. Again, I'm not a big fan of this abbreviation right here, so I think I'm going to rewrite the problem for myself. And now I can take the derivative. This sort of mixes in some earlier stuff. When I take y prime, remember there's a 1 in front. I have to do the power rule first of derivatives. 5 times 1 is 5. Stuff to the go down by a power, so that would be to the 4th, and then times a chain rule, times the derivative of what's inside. Well, the derivative of natural log of 4x squared will be 1 over 4x squared times a chain rule of 8x. The last two fractions will simplify into 2 over x, and then I can write my answer. And that's likely how you're going to see it written in most books. Okay, here's number 12. I've been avoiding the quotient rule for a while now, but here I have no choice. Because I have x's, both numerator and denominator, and the denominator is not a monomial, it's a binomial, I'm stuck. I'm going to have to call the natural log of x u. The 2x minus 3 will be the v. Just over on the side, I'm going to write u prime and v prime. U prime will be 1 over x. V prime will simply be a 2. And here we go. U prime v minus uv prime over v squared. Okay, I've got my v squared. U prime v minus uv prime. All right, I don't like the fact that I have a fraction within a fraction, so I'm going to multiply the numerator and denominator both by x. Now keep in mind up top, this is a binomial, so this x has to go through to both terms. And then it'll give me a slightly better looking final answer. Here's what it is. All right, on to number 13. This will be the last problem that we do on day 1. It's the natural log of a fraction. Now, the only reason that the absolute value is there is simply to acknowledge that we can't take natural logs of negative numbers. That's it. In fact, you can't take the natural log of a 0 either. That'll be undefined. Your calculator will not appreciate that. So don't worry too much about the absolute value. It's not mathematically going to affect your computations. Well, let's go ahead and use the fact that we have logs. We can use the rules from Algebra 2. Since this is the natural log of a fraction, let's break it up using some subtraction. Ooh, sorry for the rhyme there, jeez. Not intentional. You can make a math rap out of this. Nobody would ever listen to that. Okay, there's my subtraction. And now I've got it so that I do not have to use a quotient rule. Thank goodness, this will be much easier. I can just do derivatives. Let's start right here with the blue step. The derivative of that is going to be 1 over tangent of x times the chain rule, which would be a secant squared, minus, and then this other part, which I'll do in red, the derivative of that is going to be 1 over stuff. So in this case, 1 over 2 plus sine x. Times the chain rule, which would be cosine of x. Combining and neatening things up a little bit gives me my final answer right here. Again, please do not attempt to get a common denominator. That's needless work for both you and for myself, and you're actually making things more difficult with a plug-in later on. Now, that is one way to write the final answer. There is another way, and we do have to be aware of it. Some people may decide to take secant squared of x over tan x and work some pre-calc magic on it and change it into 1 over sine x cos x, which sines and cosines are a little more friendly, so you might see that as an answer instead. So I just want you to be aware that if you don't see the first answer, that the second answer could also be correct, and you might have to do some pre-calc to simplify and take a look. We'll get day number 2 started in a moment, and you can view that on the next video. Take care, everybody.